And if this is not actually uploading in real time, I've got a local file that I can do with this. So let's go ahead and fire up the Unity and get this going. All right, so I'm going to create a new thing because I didn't actually finish that last time. So I click New, and then I'm just going to call this Hello World Jeremy Bond, because if I were a student, I would want to actually get a grade for this. If we get a project that is named Hello World, then we won't be able to give anyone a grade on it. So put your names on your projects, please. And you might think that D2L does a good job of like labeling things with your name. It doesn't. What it does is it compresses whatever you turn in and puts your name on the compressed file, and then when we decompress it, your name is not on the thing that was turned in. So then we get like 20 files all with the same name, and it's really awful.
It also doesn't put your name at the beginning. It puts a random string of numbers at the beginning.
Oh, yeah.
You can't sort it by name.
Yes. All right. So I'm going to create this project. And here we are in Unity. Now, this is my personal layout for Unity that I believe makes it much, much easier for me to work in Unity. In general, you will probably get a layout that looks kind of like this, which I think is terrible. I don't know who this would be for, because it actually has a lot of the same things, but it's just much more difficult layout in my opinion. So one of the first things that you do in the book is you rearrange this layout. Part of that is you're going to convert this from this 2-column thing that I hate to a 1-column thing. You can turn it back, but you go to 1-column layout there. And then you start moving the project all the way over to the left, and then the hierarchy all the way over to the left next to it. And then you move game under scene. And again, this is in the book. It's described pretty well in the book. The last thing that you add as a programmer is you want to go to Window and add the console. And the console gives you various messages while you're working about things that are working well or not working well. I'm going to drop this underneath. Oh, I can't grab it by the gray bar. I have to grab it by its name here. I'm going to put underneath project and then put hierarchy next to project again, which is going to sort of space it out nicely. And then I'm going to do this, and a way that you can kind of get a good gauge for how this should be laid out is if you set the game pane to 16 by 9. Actually, I'm going to set it to 1080p because that's just going to make things better later on when we start working with UI. So if you set it to 1080p, you can see, okay, it's a little bit shorter than it should be. So you can go ahead and grab this, or just sort of get it to where, okay, that looks like it's about the right 1080p resolution. And then I can go up to here and I can save this. I can save layout as game dev mi231. And if you're on a Mac, you put an underscore at the beginning of this to sort it to the top of the list. I think if you're on a PC, you put a space at the beginning to sort it to the top of the list. But now, up here, you can pick, oh, I guess it's underscore on PC and space on Mac. But you can select that from the list and go back to that setup anytime you want. So I have a lot of these. I have one for when I'm using a tall screen rather than a wide screen. But that one that I just did is going to work out pretty well for you. Now let's look at what's going on in these. Now there's very little in the scene right now, but there is some stuff. And you can see that if you disclose this disclosure triangle here, there's a camera and a directional light in the scene. So the hierarchy is what is in your scene. So it's kind of like if you were, working in theater, or it would be what's on stage, or I guess what would the equivalent be in something like Maya? Does Maya have scenes, or? Okay. Anyway, it's everything that's actually on the screen that could be seen by a player. And we've got here a camera and a light. And you'll see that as I select them, they get highlighted here. Oh, and yours is probably... Oh, that's weird. The selection outline's not... Oh, it's not gross because these don't have actual geometry. But so you can see on the right here is the inspector. And the inspector gives you all sorts of information about each object you have selected. Every single thing is going to have a transform in the selector. And the transform does 4 major things, only 3 of which it actually shows you. So it does position, rotation, and scaling of objects. That all makes sense. The other thing it actually handles is hierarchy of objects, which I'll talk about later because it probably doesn't make sense to talk about it now. But it is the transform that allows objects to be children of other objects, right? So, like, right now you could think of that chair as a child of Mac. So if he moves his body, the chair will move with him. On me, my watch is a child of me. You know, it can be a separate object, but, you know, right now, most of the time, it is a... I can't put my watch on that. It is an object that is attached to my wrist, and so it is parented to my wrist, or it is a child of my wrist, and the wrist is a parent of the watch. There's all sorts of stuff here about setting up your camera and that kind of stuff. And this skybox thing where you can actually see the sky in the background, I'm going to show you something cool with it, and then I'm going to turn it off because I hate it. Let's look at the directional light. So the cool thing with this, by the way, I'm going to try and talk about what things I'm doing. Like if I hold down Option, you see my cursor turns into an eyeball if it's over the scene, and that allows me to look around the scene. Now here's what's fun about this directional light. By the way, this that you're seeing down here is what this camera sees. So you see when I have the camera selected, it's seeing the same thing, which you can't really tell because there's nothing in the scene. So let's go ahead and create an object. There are 2 ways to create objects in the scene. Actually, there's probably 3, but we can go create 3D object, cube. And hey, there's a cube in the scene. And you can see it's selected, and I've got this orangey glow around it that helps me know that it's selected. Another way is to say assets, assets, create, that is not right, game object, 3D object, and you'll see this is the same menu I got from clicking create, and I can create a sphere. Or I can right click and go to like 3D object and create a cylinder. Now here's a question. Why was the cube there when I created a new cube and the cylinder in this other position when I created a new cylinder? Well, and the cylinder is a little weird because the cylinder actually kind of made itself a child as the sphere, which was not my intent. But so the cylinder is at this weird position that the sphere is also at. Any thoughts on why that might have been there instead of like the center of everything like the cube was? So here's something else. If I take the hand and I do this, and then let's say I create another light, I'll create a point light. Well, now it's there. So what's happening here? Yes?
So it looks like your center point is where you're perspective.
That's exactly right. And it's really hard to know where that's going to be. It's kind of, because, you know, there's all these different ways that you can move the camera around. You can hold Option and rotate it this way. You can use this little hand tool to move it here. You can scroll in and out. And scrolling in and out seems like it sometimes moves the focus point and sometimes doesn't. So there's a lot of weird stuff going on with that. So just whenever you create something, I always assume it's going to be in some completely random position, and I'm going to have to change its position by just typing in a better position here. So that's just something to be aware of. Here's the cool thing I wanted to show you about the directional light. If I take the directional light, and oh, this is also really nice. If you click on something here and just click on it once and then move your cursor over here and hit F, it'll focus on it. So now I'm focused on the light. If I hit sphere and I hit F, it's going to focus on that sphere. And here it's going to focus on the point light if I hit F, right? So that's a nice feature to help you find things. You can also get that by double clicking here And then just recently we learned that if you have the cursor, your mouse cursor over this scene pane, and you double tap F, it will lock onto something and actually follow it if it's moving. We can't show you that because nothing is moving in the scene yet, but that's really neat for following different characters and stuff. So I'm finally going to show you the directional light thing I was going to show you. Up here are various tools, and if you mouse over them, it'll say it's the move tool, and the hand tool, and the rotate tool, and the scale tool, and the rect tool, and the really new tool that I've never seen before today. Yeah. So, and these match keys on your keyboard: Q, W, E, R, T, and even Y. What is this thing? This is like the new thing. Damn! Whoa, that is a mess. Oh God, nobody asked for that. Okay, cool. So anyway, if we move, this is also something to look at. If I look at this, see how these axes are kind of weird? They're kind of rotated. That is because these are the local axes for this point light. So you've got X to the right, Y is up, and Z is forward. And if you ask for any transform, or basically a transform, remember, tracks position and rotation and stuff. If you ask for a transforms dot right, it will give you a vector pointing to the right of wherever that thing is rotated. And dot forward will point directly in front of it, and dot up will point up. And again, that's like X to the right, Y is up, and Z is forward. And so you can see that the directional light always points down the Z axis. Knowing that Z points forward is really cool because there's functions like look at. You can tell a transform to look at something, and what it will do is it'll point the Z axis directly at the thing you tell it to look at. So what if I want to move this in regular axes? Well, that's what this is about up here. There's pivot and local here. So local toggles between like world axes, which you see line up with the world axes here, and local axes, which is the object itself. So if I want to move this object forward or back in the direction it is pointing, I can do that with the local coordinates. If I want to move it just up in the Y direction, then I do that with the global coordinates. Additionally, there's this idea of center and pivot, which I cannot show you with a light because the center and the pivot are the same on a light. However, you may have seen, like, I'm moving this light around and nothing's really changing. But if I rotate it, so I'm going to hit the E key and rotate it, now it's got like this stupid sun in the sky, and I'm sorry, I'm supposed to be pretending that's cool. Look at this cool sun in the sky. All right, and it's actually kind of nifty. It gives you like atmospheric scattering effects and all this kind of fun stuff. But rotation matters for directional lights because directional lights simulate the sun. And it doesn't matter to us which direction the sun is pointing. It's so far away, I'm sorry. That's going to be confusing because it looks like you're changing the direction this is pointing. But what matters is the angle to the sun. And if the sun were like 1,000,000 miles closer to us, it wouldn't matter to change the light that it casts because it's so far away. Rotating a directional light does change things. And you can see as I'm using this tool, like I can click on one of the, let me just zoom in here, one of the wire edges here, like this blue one, and then I'm exclusively rotating about that blue coordinate, right? And just like, oh, that's interesting. Huh. Yeah, so I don't know why, but the rotation forgot that it was supposed to be global for a second, which is a little weird. So like if I rotate this, oh, I see. So it's still got the same coordinates. I have to, like, it's because it remembers the rotation I did, and I need to switch it to local and then back to global to get back to the same sort of basic coordinate thing. Cool. So anyway, that's a directional light, and it does this cool thing on the background. But when I'm working, I often find this like atmospheric background distracting. So what I will do is click in this little mountain. Whoops, that's not what I meant to do. Wrong key. Click on this little mountain here and turn off the skybox, which will make it gray in the background, which to me is just a little bit easier to see what's going on. And then down here, this one's actually controlled by the camera. And you'll do this in one of your first projects. You just go over here and set clear flags on the camera to, instead of skybox, you set it to solid color, and then it will be the solid blue color, which just early on is a little bit easier to deal with. I think it's easier to see what's going on. Cool. I've been going kind of fast. Any questions so far? Cool. All right. So now let's, yeah, I'm sorry. 2017.3. That's, yeah, that's the one that if you go to the website, you can download like today. It probably came out just a couple of weeks ago. And I'm really hoping that it can be the version that we use for the rest of the semester. I don't actually know what's on these machines. They are almost certainly out of date. But yeah, 2017.3 so far added this thingy, which, you know, allows all the craziness to happen because you can scale. Oh, that's funny. Oh, it's a camera. Cameras don't scale. So here's a sphere. You can scale it. Ooh, right? And you can move it. By the way, with the move tool, this means move in the same z plane. So move in x and y without affecting z for the blue one. And the red one means move in y and z without affecting x. And it's just like 3D is hard to navigate. This makes it a little bit easier. And then of course you've got like it's kind of an interesting thing. I might use it, but I'm just getting used to it right now. All right. It's a lot to look at. Yeah. It's a little busy. Cool. So over here on the side are components. And this is explained a lot more in the book, so I'm going to rely on that to do a large part of it. But the transform I already talked about, right? Transform sets position, location, position, rotation, and scale. Then there's the mesh component. And the mesh component is the actual dots and lines and triangles that make up this sphere. So that is like a model that you modeled in Maya or something and brought in. That's going to be the mesh component. Then the mesh renderer actually allows us to see that. So this mesh renderer, if we turn it off, the object is invisible because that is the piece that's rendering. And the nice thing is you can have any kind of mesh, and a mesh renderer can render it the same way. And that's sort of the idea of components, which you'll actually encounter in coding when we get to the Dungeon Delver project. It's this idea that you make small things that do a very specific job and all work together in concert. The early part of the book doesn't do that because usually it's hard to do that as a new programmer, but I wanted the last chapter in the book to really get into that. And then the collider is a different thing. So you'll see, again, when I turn off the mesh renderer, there's still like this green circle. And that green sphere there is the physical presence of the sphere. Lots of times in Unity, you will not, like, you want to have a collision for, say, the body of your character. And like your character has like 2 arms and 2 legs and all these fingers. And so you might think, oh, I'll do like all these like capsule colliders, and I'll do a capsule for each joint of the pinky finger. But collision is actually really slow. It's much faster to draw something than to figure out whether it has run into something else. Which is why, like, even in like a really recent game like Horizon Zero Dawn, you'll see that Aloy's hair sometimes goes through her clothing because it's a really hard problem to do collision quickly. So a lot of times what you do is simplify the collision. And so the collision is not the same as the mesh. You don't do the exact surface of the object. You're just like, oh, you know, a person's about 2 meters tall and about this wide. I'll just do a capsule, and that'll be a person, and it'll be fine for 90% of what I need. And so that's why the collider and the mesh are different from each other. You'll learn about triggers versus regular colliders soon. Cool. So now let's just look at this thing, and I'm going to turn the mesh renderer back on. I'm going to move the sphere over here a little bit, and then I'm going to hit play. Nothing happens, right? And that's because we haven't added any physics to these objects, right? So one of the things that we need to do is add another component, and I'm going to go to Add Component, and there are lots of different components listed here. The one we're going to add now is under Physics, and there's Physics and Physics 2D. I generally work in Physics, which is three-dimensional physics. That's probably mostly historical because the 2D physics used to be very unreliable in Unity. It's gotten a whole lot better, so for your custom project, you might want to try working with Physics 2D if you're doing a two-dimensional game. But still, pretty much all of the 2D games that I personally make, I use 3D physics for because I have found it more reliable. And we're going to add this thing called a rigid body. And a rigid body is named after something in physics, right? So this, wait, I got the eraser. Perfect. All right, so let's look at two different erasers. This is a rigid body, and this is a soft body. And the big difference is that if you drop a rigid body, it doesn't deform. And if you drop a soft body, it does deform, right? So soft bodies actually deform when they hit things, and rigid bodies don't. And, you know, that's the difference. There aren't soft bodies in Unity. It does have some kind of things that kind of, like it has a cloth thing that kind of tries to fake it. But in general, everything you're going to deal with is a rigid body. And the rigid body here, you can see, has a mass. By the way, Unity works in a metric system, which is really nice because the metric system is way better than what we use, except for temperature. And so this mass is basically 1 kilogram of mass. And any unit in Unity is like 1 meter. So if you look at my capsule that I made, that or I guess the cylinder, here I'll make a capsule because I've been talking about capsules. Cool. All right, so I got a capsule here. So this capsule is generally, it's 2 meters tall and about 1 meter wide. And so it's roughly the size of a person in a video game, right? And so, you know, Unity units are about 1 meter or about a yard. They're exactly 1 meter and about a yard. And other things in it are basically set in metric kind of ways. So our sphere here that we added the rigid body to has a mass of 1 kilogram, which is really light. I probably weigh 60 to 70 kilograms. And drag is, I don't know what drag is in. Drag's probably percentage. It's probably like friction where it's a percentage from 0 to 1. Angular drag is how much it'll slow down just falling through space. Angular drag is how much it'll slow down its rotation. And then there's this use gravity check. And what use gravity does is you hit play and it uses gravity. Yay, look at it go. Gravity. All right. The other thing is, like if I move it up here, you'll see that it actually collides with the other objects because they came with colliders and it bounces off of them, right? So that's kind of nifty. It's also off to the side a lot, which is why it did. There we go. So you can see that it actually has some pretty cool physics. Then there's all sorts of little details in here that you'll learn more about later. And then the last thing is, in your mesh renderer, there are materials, and you can have multiple materials per object, though generally you just have one, and then that is down here. And there's all sorts of different things about the materials here to make it look crazy different ways. All right, so that's a little bit about the inspector, the hierarchy, and the project is actually the folder on the computer that stores a bunch of your files. It's the assets folder within your actual project folder, which is a little bit confusing because there's a project folder that contains something called assets that is really what's the project thing here, but that's been that way since the first couple versions of Unity, so we're kind of stuck with it. But if I were to save this scene, because man, this is a masterpiece, I'm going to save it, and I'm going to save it as scene 0. I tend to put underscores in the name because on Mac at least it'll sort it to the top of the project window. I think on PC underscores get sorted. Oh, it does. Good. Okay, great. And now if I were to right click on this and say reveal in Finder, you can see this is my project folder, this Hello World Jeremy Bond, which is on my desktop. And then in assets is scene0 Unity, the actual scene file. When we tell you to turn your project, don't just turn in scene0 Unity. It'll be completely useless to us. You need to turn in this entire Hello World - Jeremy Bond, obviously not Jeremy Bond for you, folder. And this temp kind of comes and goes. That is all the random files that Unity has that it's working on while you are in it. So as soon as I quit Unity, that temp folder will go away. The library folder, you can see, has a ton of stuff in it. It is 15 megabytes right now. I don't know what's in here, but it's kind of important. So you should make sure that that gets turned in too. Wow, that's really big.
If you're going to be copying your folder into a zip file to submit it, you can't do that while Unity's open because there's a lock file that will not let you do that. So when you're done with your project, close Unity, then you copy your folder over.
That's a really good point. Anytime you try to move a Unity project folder while Unity is running, Unity will hard crash and yell at you. Yeah. I've never seen it actually damage anything, but with the lock file, it could. It could just tell you somebody else has that project open in Unity, you can't open it. And how would you do? Would you delete the library folder and just hope for the best?
Probably.
Yeah, yeah. Or at least delete the temp folder. Maybe it's in the temp folder.
Well, if you try to copy it, it'll give you a warning. It'll say, like, I can't copy this file, and then it'll stop your copying.
Yeah, but if you actually move the folder, Unity doesn't have any control over that. And so Unity just like, whoa, 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 and it just crashes. So I kind of wish Unity would say, something bad happened. I'm just going to go back to, but no, it just crashes. Because Unity is constantly in the background opening and modifying files. It has like hundreds of files open right now that it's modifying anytime I change something. All right, cool. So let's create a new scene. I just hit Command N or went under File to New Scene. And we're going to start doing a tiny bit of code. Now, and this is what the console window is open for down here. Now here, I'm going to be smart this time. I'm going to save my scene first. Scene 1. All right, great. Now I've got it saved over here. And I'm going to create a script that's going to allow me to code. In Unity, we use this language called C#, which, honest to God, is the best language I have ever used to teach students how to code. Maybe if you learned Python, you'd be better at tabbing things in properly. But C# is just a fantastic language to learn as your first language if you're not familiar with other languages. To create a new script, I go up here to Create, whoops, and I go to C# script, and it makes a script. And I'm going to name this Hello World. This is similar to what you will do in the Hello World chapter, but I'm going to try and do it a little bit differently so you can see a couple of different things. Now, if I hit play, nothing's going to happen. And in fact, still, even if I... Sorry, I'll approach that differently. There are two things I must do for something to happen. The first is I have to actually put the script on an object in the scene. Right now, it's just sitting in that folder that we looked at in the Finder. But it's not actually told to do anything because it's not part of the scene. So I can take it and I can just drag it over to the main camera. Like that. And you'll see you get the little curvy arrow there and release. And now when I select main camera, Hello World is another component that's been added to main camera. And what's super cool about that is you can have multiple scripts on the same game object. Again, I don't do this a lot early in the book, but later in the book, there's lots of scripts on game objects, and that's generally how I tend to program now. So once something is attached to an object in the scene, it actually gets several calls to it by the Unity engine that we'll talk about in a second. But while this is launching, does anyone want to guess at why I might have attached it to, really? Sublime? Okay. I mean, like, Sublime's cool and all, but that's, okay. Sorry. Does anyone want to guess as to why I might have attached it to the main camera? Yeah.
So that it's seen by everything. So if you attach it to the camera, it means it's always on the screen.
Right, so the camera is there's only one main camera in each scene. You can have multiple cameras, but only one of them is the main camera. And so it's easy to find where something is. The other thing is every scene has a camera. Without a camera, the scene would just be black. And so in a lot of the early projects, I put it on main camera because like it's just if I'm trying like, man, where did I put that thing? I generally was like, oh, well, I'll probably put it on the camera. If it's like a player script, I'll put it on the player, obviously. But for something like that, it sometimes makes it easier there. Oh, geez, that is so. See, it says monodevelop here, but it didn't open monodevelop. Okay, I've never seen that before. So what happens if I double click here? Hey, Sublime, how you doing? Okay, so I don't know why this problem is happening. See, 2017-3.0. But I'm going to go External Tools, and I'm going to go to Browse, and I'm going to go Find Unity. And click on old monodevelop there. Yeah, uh-huh. Okay. No, I've been quitting Sublime. Okay, so this is why it's happening. I don't know why it's never happened in Unity before, but I have set my default app in my operating system to be Sublime because, frankly, it launches a lot faster than monodevelop and allows me to open things in the Finder differently from the others. So this is dumb, but I'm going to have to go and select it this way, which I am shocked by. Okay, so now it should be that when I double click on this, it actually opens up monodevelop. Oh, I can, yeah, I see. I'm just pissed. I see it. Okay, great. So, hey, here's what we're going to do. We're going to save, and we're going to go back to the previous version of Unity because that's what you do when this happens. So I'm going to go, and I'm going to right-click on Scene 1 and say Open With, and I'm going to do 2017.20F3 and see if this one works. And if not, I really don't know what I'll do. Because this is a new problem. So you can open Unity in a project in a previous version. It'll just be like, oh no, it doesn't work. And in general, it's probably okay. Sometimes they make really big changes and then it really doesn't work. But in general, it's usually okay if it's a minor version change like that.
You're not going back to like.
Well, I don't really care about that. This is really annoying. All right. Oh, hey, cancel worked, I guess.
Yeah, as long as it's 2017, it will probably work. But for the sake of being consistent with what we're showing,
yeah.
Probably follow what we're using.
Okay, yeah. So let's see if this works now. I can tell it worked because it's taking forever. See? And monodevelop always takes forever. All right, there we go. So maybe not the 2017-3. Yeah, so what I'm going to recommend to you is if you go to unity3d.com and then you click on Get Unity and then click on Try Personal and then looking to download the installer for Windows, choose Windows. Click this down here. Oh man, come on, don't be stupid. All right. Scroll down to the bottom of this and there is older versions of Unity under Resources. And here you can say, oh, I'm going to pull 2017-2.1 and download that Unity installer for that. In fact, I'm going to do that now. I'm not going to install it now, but I just want to have that because that's better than the junk I was dealing with. Man, I told you, every 0 version is bad. Okay, so monodevelop. By the way, in monodevelop, if you hold down Option and scroll, you can increase the size of the text, which is super useful for this class. And here, I've got a couple of these things that I set, these calls that get made to scripts whenever they're attached to something. So a call is whenever you tell a script to do something, to call a function. And a function is just collected functionality. So, for instance, there could be a function that Mac had that was like turn on the light, right? And I could say, Mac, turn on the light. And that would be calling the turn on the light function, and you would turn the light on, right? And so that's basically what's happening here. Start is called on any script right before the first frame that it exists in the scene. So if you create a new object, start is going to be called right before it actually shows up on the screen. And then update is called every single frame. Now, when we talk about frames, you can think about like the frames of a movie. You know, you've seen like movie strips, and it's got individual frames. Every frame, Unity is calculating all these different things and showing it on screen. And right before it shows things, actually, it's probably before it calculates things, it calls update on every single object that's on screen. So let's start here, and we'll say print hello world. Now, this is also a function. There's a function called print, and I'm passing in a parameter hello world, which I'm just telling it what to print. Again, this is described in much more detail in the book. So if I save this by hitting Command S and go back, Unity will compile it, and then when I press play, it now oh, you know what? Oh, right, I disabled. So there's 3 different kinds of things, and I disabled one of them. Wow, hello world. Oh my God, it works. It's the best program ever. So now, what will happen if I take hello world, print hello world, and I put it into update? What will happen? Yeah, it'll happen continuously. So now, what will happen is I hit play. And now it's going over and over and over again. You can see the count of it here. And I can collapse this, and you can actually see it increase like very quickly. If I click on the stats here, you can see that our printing hello world is running at about 35, 55 frames per second. All right. Ironically, when you get to coding a bunch of stuff, you'll actually find that printing to this window is one of the slowest things you can do in Unity. So you don't want to print too many things to there. But yeah, we've got almost 1,000 printed here now. So I want to do something other than hello world. And the hello world is like a really old programming thing. It's usually the first thing you do is just get the program to say hello world just to show that you can do it. So now I'm going to do a much more Unity style hello world. I'm going to create a cube like I did before. So I'm going to create a 3D object that's cube. There it is. I'm going to set its position to 0, 0, 0. Oh, I hate 2017. You have to hit tab to the field, and then I can type numbers all I want, and it doesn't do anything. I have to hit return, and then 0, and then return. I hate it. Yeah. Oh, that's true. I could go here and go to reset here. Yeah. Yep. Absolutely. I thought you were going to tell me how I could make the tabbing work properly. Oh, man, that would have been amazing. All right. No, that's cool. I would have loved it, though. All right. Cool. So, and again, we're going to add a component now. We're going to add physics rigid body, just a regular rigid body to this. And now when we hit play, hey, the box drops. Cool. All right. Now, what I can do with this cube is I can drag it into the project pane. As you can see that I'm doing there. And now a couple of things have happened. One is cube is blue here, and the other is there's something called cube in the project that has this cube-shaped icon, but it's actually not. It's always a cube-shaped icon. It doesn't matter that it's actually a cube. But that's the icon for what's called a prefab. And you can think of a prefab like a mold. So I can drop in several different instances of this prefab and then move them around, and you can see that all of them look the same. Here we go. There's another one. And they all act the same. They all have the same rigid body on them. And they all, actually if you scale the prefab, you will see that it scales all of them, which is kind of cool. But if you scale one of them its own way, like this, and then you scale the prefab, the local version I guess of just that dimension overrides it. Yeah. Oh, that's interesting. It used to be the whole thing, but now it's just that one dimension. Cool. All right. So that's what a prefab is. It's like a mold that you can use. And one thing that is really neat that you're going to do all the time in Unity is you're going to instantiate these prefabs using code. So now I'm going to instantiate a thing that is a game object. And these angle brackets is what I'm going to call these greater than less than signs. These angle brackets just say, okay, instantiate what I want from you is a game object. Because instantiate can instantiate all sorts of things. And what I want is a game object, which is everything you see on screen in Unity is a game object. The light's a game object, the camera's a game object, characters are a game object. A game object is a thing that holds a transform and a bunch of components. And, well, which game object? So now what I need to do is create a variable to hold which game object. So I'm going to say public game object. And I'm just going to call this one cube prefab. Now again, there's a lot of stuff going on here, and it talks all about it in the book. But game object is the type of thing that I'm making, and the variable name is cube prefab. Public means that anybody can see it. And anybody actually includes, and we might get an error from this line, so I'm going to comment it out real quick, actually includes the Unity inspector. What? That's not even, oh, maybe I didn't save it? Like, that's commented out. Why is it complaining about commented thank you? All right. So now, look at that. Cube prefab, spelled in a really weird way, shows up here. And I complain about this because I think it's really confusing to students to see that it like adds spaces in between the different parts of the word. But it's still the same thing. And now I can just take this little cube and drag it over there, and that assigns that cube that we made to the cube prefab variable. And now we can call this with cube prefab as the thing we are instantiating. And I save this and I come back and there's no errors. And now when I press play, hey, look, a cube showed up, right? We made a cube, and you can see it shows up here as cube clone. We can actually do this FF thing now, and you can see it's focused on the cube as it's falling. You can see the position over there, the Y, keeps decreasing. Well, that's pretty cool. Well, now what will happen if I need to recenter on like the world here. There we go. Now what will happen if I were to say take this and move it into update? What do you think will happen? Sure. It actually doesn't. That's the cool thing about Unity. Like check it out. I think this is what you were thinking, right? Look at that. And let's check out these stats. It's still running at like 60 frames per second. And remember, I'm recording a video at 1080p and sending it to YouTube right now. And it's still running at 60 frames per second. And you can see that all these objects still exist. Like this scrolls for a long time. And like I can look down and they're all down there. All right, so somebody who has not answered a question yet today, why are they doing this? Why are they like all shooting out all over the place? Right, they're colliding. So they inhabit the same space. And the colliders are like, whoa, 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 and they push them apart, and that gives them an initial velocity. And so they all spread out. So anyway, I mean, you can see I've got 8,000 vertices, 3,000 triangles, you know, and I'm still rocking 60 frames per second. So Unity physics is very, very fast, and Unity in general is very, very fast. Which brings up a point. If any of you have some experience in computer science, you might be tempted to think about efficiency when you're working in this class. Just don't worry about it. I was an intern on the game Spore, and I was working with Chaim Gingold, who was the creator of the Spore Creature Creator, which is definitely the best part of Spore. And we were trying to figure out a solution to this problem, and I was like, man, I'm really worried that it's going to be inefficient. And he looks at me and he's like, Jeremy, computers are fast, man. Don't worry about it. Let's just remember that. Remember Chaim saying computers are fast. Like, only worry about it when your frame rate drops, and then we can talk about making things more efficient. And you know, you'll probably find ways to do it, but just don't think too hard about efficiency, especially as a new programmer. Now we're up to, you know, we're down to 30-some frames per second, but we've been running this for a while. I should have left the print in there so we could tell how many objects there were, right? All right, cool. So this is part of what you're going to be doing for some of your first homework, and this homework is going to be posted to D2L. We're going to basically do it. Going to go and post it immediately after class. I already kind of gave you a heads up on the code combat assignment. That's not due until Wednesday. That's why there's no Dropbox for it or anything yet. But there's the code combat assignment just to get you started in thinking about variables and that kind of stuff. I found in previous classes that really helped to just kind of kick off the discussion of coding. And then your other assignment for Wednesday is going to be to just go through the Hello World chapter in the book, as well as a couple of other chapters that I ask you to read. And then there might be a quiz on Wednesday about what goes on there. So just to play around with this a little bit more, let's go ahead and add that print. I made a cube. All right, so we got I made a cube there, and then we got instantiate. But this is really cool. We can actually create a new variable that I'm just going to call go here. This cube prefab instance gets put into temporarily. So we've got our game object named go. Now, this public variable up at the top is kind of a variable for the whole class, and that's why we can see it in the inspector and edit it. This is just a temporary local variable. As soon as the update function ends, this go is not going to mean anything anymore. Which is why, like up here in start, I can say cube prefab, and it's black because it knows what that means. But if I put go, it's like go. Yeah, so there it turns it red because it doesn't know what it means. Okay, cool. So now I can do some cool stuff with Go. So for instance, they're all right on top of each other. But let's say I wanted to just move them a little bit outside of that. So I can say, oh, go.transform.position. And this is, again, using that component thing. I've got the game object, and the game object has a transform, and the transform takes care of the position. So I say go.transform.position equals, and this is going to be random dot, and like you just, one of the toughest things about learning a new language is like, well, how does he know that it's random? And how does he know that it's inside unit sphere? This is stuff you start learning, and there's really good documentation for it. So let's say, I was like, man, I want to do something like kind of in a random space, something randomy, random. And then I can click on random and go under help to Unity API reference. And that will launch, I guess Firefox. It'll launch a browser and open up the API reference for Unity. Now this opens up the online one, but there's actually a local one as well installed on your computer. And there's all this stuff related to random that showed up. And I want to make sure and click C# here so I'm not doing JavaScript. And then click random. And you'll see, okay, I got this random thing that does random data, good. And there's all these different properties on it. Inside unit circle, inside unit sphere. Well, inside unit sphere returns a random point inside a sphere with a radius of 1. So that will give me, if 0, 0 is right here, and I've got about a meter on either side, it'll give me a point somewhere inside this sphere. There's another one there on unit sphere, which gives you something on the very edge of that sphere. But if I call inside unit sphere, it's going to give me a random point near 0, but not at 0. So I go, okay, random. Oh, it's actually a value, not a function. So it's just dot inside unit sphere. And now that'll position that block not exactly at 0, 0, 0. And so if we save this and run it, you can see that it gives it actually a little bit better effect because they're not always colliding in the same way. It gives it more of a kind of waterfall effect and a little bit less actual like velocity given to things. Also, I can go to my cube here and I can say, hey, I'm going to add an effects component called a trail renderer. Trail renderers are just, it's kind of like Unity's just make it awesome button. So we don't have to do this shadow stuff, but I'm just going to be fast. So materials, I need to add a material, otherwise it's going to be this awful magenta color. And it turns out there actually is a default particle here, which I guess is the one to use. Yeah, sure. We'll do default particle. We'll see how that goes. Material, and then I say, okay, well the time we'll set it to 2 seconds. And the width is going to be 1. And then this is this cool little editor where you just kind of double click to add a point. And you can move that point up and down. And now it's going to taper down from like 1 to 0. And now when I hit play, because I modified the cube, now all of them have these cool little trails on them, which is kind of fun. And I can do more stuff. I can go into MonoDevelop. I can say, oh, well, I could also change the color of each thing. And this is probably the last thing I'll do based on time. But let's say we want to get to the color of the cube. So if I go back to Unity and I look here, go away, trail renderer. Okay, cool. And I look here, I'm like, okay, so there's a cube and it's got a material, which weirdly doesn't show up down here. I've never seen that not show up. That's so weird. Yeah. Okay. So it's supposed to have a material down here. That's the default material. But we can double click it and you can see that there is a white material here. This one we can't edit because it's the default, but you can edit it in code. And so, well, to get to that material, I had to go to the mesh renderer, which is a renderer. So now I can go in and I can say, okay, well, I'm going to have renderer rend equals go.getComponent renderer. And so that pulls that renderer component and gives it to me. And so I can say rend dot, and I'm going to say it's dot material dot color equals new color, and this will be random dot value, which you can see here returns a random number between 0 and 1 inclusive, which means it could be 0 or it could be 1. So random dot value, random dot value, and again you can see float RGB constructs a new color with given RGB components and sets A, which is alpha, to 1. Random.value. And if you were to click on this and then under help go to Unity API reference, it would take you to the color description and it would talk about making colors and all that kind of stuff. Constructor is what is used to make the color. So if you click on this, it says, oh, I take in RGB and A, or just RGB, and it shows you that it should be between 0 and 1. So now what's going to happen is each one of these is going to be a different color. And hey, there you go. Yay. And that's most of what you're going to do in the Hello World chapter. Cool. So that's it. We're exactly on time. We're a minute late. But anyway, welcome to class. We're looking forward to it. Yep. Awesome.